Algebra is one of those words that when you hear it, it sounds really scary. And in fact, you'll often hear a lot of adults talk about algebra as if it's this unknowable thing that's difficult for normal people to understand. That's actually not true, because algebra starts from a very simple idea. What if we just did all the same math we know how to do already, but we don't yet know what all the numbers are? Now, there could be many reasons why we don't know what the numbers are. One typical reason is we really want to know what a number is, and we haven't figured out what it is yet. So we can use algebra to help us figure out what the number is. The other reason we might not know what a number is because we want to let that number change in different circumstances. Sometimes we might want it to be 1, sometimes we might want it to be 2, sometimes we might want it to be 73. Well, it turns out we can still do math on those numbers without actually knowing what the numbers are. That's what algebra is. So a variable is a quantity whose value we don't know yet, or whose value can change. A variable is usually represented by a letter. An algebraic expression is an expression, like the numerical expressions we were looking at in the last lesson, but which contain variables as well as numbers and operations. If we know the values of the variables, we can substitute the variables by replacing them with their values. This turns an algebraic expression into a numerical expression which can be evaluated. Now, you should always surround values with parentheses when substituting. We won't get into the details why right now, but it is a very good habit for you to start building from this point on. Let's look at some examples. So suppose that A equals 5, B equals -7, and C equals 2. So in this case, A, B, and C are our variables. However, because we're just practicing at this point, we're being told exactly what their values are ahead of time. So A has the value 5, B has the value -7, and C has the value 2. So if we want to evaluate 2A plus 3B, we need to replace the values A and B by substituting. So A becomes 5, in parentheses like we said before, and B becomes -7. At this point, our algebraic expression has become a numerical expression, and we can evaluate it just using the order operations that we're already familiar with. So 2 times 5 is 10, and 3 times -7 is -21. And we can write plus -21 as subtract 21. It's a more convenient way of writing it. This evaluates to -11. Now, even something more complicated like the square root of b squared take 4 times a times c, we can still evaluate this by replacing each variable with its value, that is, by substituting. So b becomes -7, a becomes 5, and c becomes 2. Now, a radical is a grouping symbol, so we need to evaluate what's underneath the radical before we do anything else. If we have -7 squared, that's positive 49, and 4 times 5 times 2 is 40. 49 take 40 is 9, so we have the square root of 9, which is 3. Now, like in our last lesson, sometimes we have expressions that are described with words. What's different here, though, is sometimes we're describing a number we don't know the value of. In that case, we need to write down that number using a variable. For these examples, we're going to use n as our variable. So triple the sum of a number and 5. So the sum of a number and 5 is n plus 5. And we need to multiply this by 3, using parentheses, of course, so that we do the addition first. 10 less than the square of a number. So, firstly, we need to square the number. So that's n to the power of 2. 10 less than this, we get by subtracting 10. Next, we're asked to evaluate each expression where the value of a number is 2. This really means that n equals 2. So we can do this by substituting. We take our expression and we replace n with the value 2. 2 plus 5 is 7, and 3 times 7 is 21. We can do this with n squared take 10 as well. So we replace n with 2. 2 squared is 4, and 4 take 10 is -6. Then we're asked to do this again, But this time the value of our variable is -8. So n equals -8. So when we replace n with -8, we can evaluate the expression and we get -9. And if we replace n with -8 in the second expression, we can evaluate it and get 54. Let's look at how we might do this with a word problem. Penelope's Perfect Pizza sells large pizzas for $6 each and also charges $8 for delivery. So the first part of the question asks us, choose a variable to represent the number of pizzas delivered to a customer. We can choose whichever variable we want, but I'm going to use P because that's a convenient way of representing pizza. When you choose your variable, think of something that will be easy to remember. So we write down, let P be the number of pizzas delivered to a customer. Then it says to write an expression representing the total cost to a customer. Well, the cost of the pizzas is going to be 6 times the number of pizzas. We don't know the number of pizzas, but we're using P to represent it. So this is 6P. Then we also need to include the $8 delivery. This is being added onto the cost of the pizzas, so we get the expression 6P plus 8. Now we're asked to use the expression to find the cost to a customer who orders 4 pizzas. So this really means that P is equal to 4. If we substitute 4 into our expression, we get 6 times 4 plus 8. 6 times 4 is 24, and adding 8 gives us $32. Parts of an algebraic expression. Terms are the parts of an expression separated by the plus and minus symbols. A term is often written as a product of a number and variables, sometimes with exponents. The coefficient of a term is the number which multiplies the variables in the term. The sign of the coefficient is determined by the operation before the term. A constant term is a term which doesn't contain any variables. It has this name because its value can't change, because any number just always has the same value. So in this example, we're looking at the expression 2x squared plus 3xy take 7y squared plus x take 9y plus 14. Now this looks very scary, but it's okay. We're not actually being asked to do anything mathematical with this expression. We're just being asked to read it and write down some information based on what we see. So firstly, we want to list what the terms are. So these will be 2x squared, 3xy, negative 7y squared, x, negative 9y, and 14. Next, we're asked about the coefficients, which if you remember, these are the numbers that multiply each term. So the coefficient of x squared is 2, the coefficient of xy is 3, the coefficient of y is negative 9, the coefficient of y squared is negative 7, and the coefficient of x is 1. Finally, we asked what the constant term is, and this is the term that doesn't contain any variables, which is 14.